Since example 3 was so long, let's recap what we found. We wanted to find the roots of a polynomial p of x equals x to the fifth plus x to the fourth minus 5x cubed minus x squared plus 8x minus 4. In other words, we were finding solutions to the equation p of x equals 0. We first found the roots x equals 1 and negative 2 of p of x using the rational root theorem. And then since x equals 1 and negative 2 are roots of p of x, the factoring theorem told us that we could write p of x as x minus 1 times x plus 2 times some other polynomial q of x. To get q of x, we had to divide both sides of this equation by x minus 1 times x plus 2. And dividing, we found that q of x was x cubed minus 3x plus 2. Now using the zero product property, we see that p of x is 0 also when q of x is 0. Because if q of x is 0, then p of x is x minus 1 times x plus 2 times 0. So to find when q of x was 0, we had to do the rational root theorem again. And using the rational root theorem, we found that x equals 1 and negative 2 are also roots of q of x. And since x equals 1 and negative 2 are roots of q of x, the factoring theorem tells us that we can rewrite q of x as x minus 1 times x plus 2 times some other polynomial m of x. And we found m of x by doing polynomial division again to get that m of x had to be x minus 1. Which means that we can write q of x as x minus 1 times x plus 2 times x minus 1 again, our m of x. Finally, we brought this back to p of x to write it in factored form. Doing this, we get that p of x is x minus 1 times x plus 2 times q of x, which is x minus 1 times x plus 2 times x minus 1 again. Simplifying this, we get that p of x is x minus 1 cubed times x plus 2 squared. From here, we could conclude that the roots of p of x are 1 of multiplicity 3 and negative 2 of multiplicity 2.